This question is from GATE 2015, Mechanical Engineering paper, Set 3, question number 49. A shaft of length 90 mm has a tapered portion of length 55 mm. The diameter of the taper is 80 mm at one end and 65 mm at the other. If the taper is made by tailstock setover method, the taper angle and the setover respectively are dash. So as per the given information, the tapered portion of the shaft looks something like this. 80 mm is its diameter at one extreme end and 65 mm is at the other extreme end. The length of this tapered portion is 55 mm. So have the clear idea that length of the tapered portion is 55 mm while length of the shaft is 90 mm. Now angle of taper is this angle at which the surfaces are being inclined. So this angle that is formed by the inclined surfaces, the point where they happen to meet is nothing but the angle of taper. Let this angle be alpha. So we have projected a line from this point where the angle is being measured throughout the tapered portion. And we can draw lines parallel to this center line like this. So throughout, this diameter is 65 mm. We can find out this angle. This will be half of alpha by 2. To find out this angle, if we write tan of alpha by 2, in this triangle, tan of alpha by 2 can be defined as x by LT. LT is already known, 55 mm. We need to find out x. X can be found out by using 80 and 65 mm diameters. So x can be written as 80 minus 65. So 80 minus 65 gives these two portions, and these two portions are equal to each other. Both of them are x's. So 80 minus 65 is 2 times x. X will be 80 minus 65 by 2. This gives us 15 by 2, that is 7.5. Let's substitute it here. Tan alpha by 2 is 7.5 by 55, and therefore alpha by 2 is tan inverse of this value, which comes out to be 7.813 degrees. We know alpha by 2. We can find out alpha just by multiplying this by 2. So the taper angle that we finally get is 15. 2 times 7.813, which is nothing but 15.626 degrees. This can also be written as 15 degrees and 37 minutes. So this is the first thing, taper angle. We have to also find out the setover. So setover is being defined as rate of taper T into length of the complete shaft divided by 2. So length of the complete shaft is known to us, 90 mm. We need to find out the rate of taper T. Rate of taper T is given as the difference between the diameters 80 minus 65 divided by length of the taper, that is 55. This is calculated as 0.273. Let's use the value of T and L from here to find out the setover. So we have setover will be 0.273 into 90 divided by 2. This amounts to 12.273 millimeters. Why millimeters? Because this is a ratio of lengths. It does not have any unit, and L has a unit of millimeters. So the unit of setover becomes millimeters. We have our two answers with us. One is 15 degree 37 minutes and another is 12.273 millimeters. Let's mark the correct option. So as per our calculations, the correct answer is option A, 15 degree 32 minutes. We got 37 minutes. It's almost equal. And 12.16. We got 12.273. So it's almost equal to 12.16 millimeters. Option A. To learn more about tool geometry, you can refer to the NPTEL video Lecture 3 on tool geometry from the course lecture series on manufacture processes 2 by Professor A.B. Chattopadhyay, Professor A.K. Chattopadhyay and Professor S. Paul. They are from Department of Mechanical Engineering, IIT Kharagpur. I hope the solution will help you clear your doubt. Thank you.